Okay, so yes, solving quadratic equations using square roots. All right, so we've already learned this from the last chapter that we are looking for where it crosses the x-axis. Okay, what does the equation equal on the x-axis? Y equals 0. Okay, so we're looking for where does the equation equal 0. All right. We're looking for where it crosses the x-axis. Either way you want to put it there. So that's why we have, and you don't need to write this down. That's why it's also called 0. But we're going to set these factors equal to 0. We're going to solve, or we're going to solve by, again, we're getting x equals here now. Before we were graphing, now we're getting what is x equal? Where does this cross the x-axis? Okay, that was something that was kind of in a gray area when we were doing the last chapter. We did a little bit of factoring, not a lot, or we just saw where it crossed by using a calculator. This chapter, we're actually solving and we're finding those, okay? So, without knowing anything, go ahead and tell me what x equals on your paper. So what does x equal? 1. Okay. Does it equal anything else? -1. Okay. Because if I say -1 squared, and -1 times -1 is +1. Okay, so that's me not even teaching you anything. Okay, that is just strictly, hey, I think I can figure this out without doing any other type of math. Okay, so how we're going to solve these problems, how do you get rid of a square? What do you think is the opposite of a square? A root. So basically, the rule says, my rule says, if you put the square root, you have to put a plus or minus. Okay? What I mean by that is, if I do a square root of both sides, I have to include a plus or minus. If the square root is already in the problem, you don't put a plus or minus there. Okay? But if you put that square root there, you have to put a plus or minus. Okay? Because then I can look at it and say, square root of 1 is 1, but I have plus or minus, so that's how I get my plus or minus. We want those two solutions here on all these answers, okay? At these two. Now remember this feeling of these problems and how straightforward they are, because as good as you feel right now solving these problems, trust me when I say these are the most missed problems in this chapter. They're the easiest, but they're the most missed. And the reason for that being, it's one of the first things you learn in the chapter. And when we start getting into the other methods of solving, there's 3 things involved. There's only 2 things involved here, okay? And first, I don't know what it is. It pops up on a test and you're like, I don't even know where to begin. I'm so used to factoring. I'm so used to doing this. I'm so used to doing that I see two things pop up in front of me and I don't even know where to begin. Okay, so hold on to this feeling of how simple these are. Okay, don't let them trip you up on a test. All right, so if I want to get rid of the square, take the square root, I include my plus or minus. As simple as that. Okay. A lot of people will forget the plus or minus. That's why it's missed. Okay, so don't forget those. Here as well, I can take the square root, include my plus or minus. So from yesterday, we know that the negative underneath the radical means I. Okay. Notice how on all three of the problems we have done so far, x squared is already by itself. Don't get square root happy and start square rooting everything. You can only do that when x squared is by itself. Okay? Any questions on those? So what we learned yesterday is going to be our next steps kind of thing. Okay? Can we reduce it? Can we reduce the radical? Oh, we have a negative underneath the radical. I need to put an I. Remember I told you yesterday was how do we write our answers? This is how we're going to do it. Okay? So, is x squared by itself? No. Now, 4 is a perfect square, and it's tempting to go ahead and take the square root of both sides. You won't get the same answer. Okay? So, we first have to get x squared completely by itself, then solve the problem. Get rid of our 4. And we take our square root. We have to include the plus or minus. Then I ask myself the question, can I reduce the square root of 5? No, it's a prime number, so I'm done. Okay? But if it can be reduced, you reduce it. All right? Go ahead and try this one. Okay, so I get rid of my 8. $96 divided by 8 gets me 12. If you need to go old school math, especially if you're not given a calculator, and then when I say old school, I have to say like really old school because they don't teach it this way anymore.
Oh, it's so dumb. So apparently you have to you divide by 90 and then you divide by 6. That's how I saw it once. So
there's multiple ways.
Yeah,
It's
you split up the 96 to 90 divided by 8 and 6 divided by 8.
Well, long division was like my thing.
Oh, good. That's in the next chapter.
Awesome. I was so good at long
I
division.
was so
It is, I mean, it's like,
She's like,
I was decent at it until
No, it's
Because it looks like you're doing a lot of
right?
work.
It
I
is.
was decent at it.
Then you're gonna love
I was
polynomials.
decent at it, and I got to like really long numbers, and then I was like,
A lot of
Fourth
times
grade
they'll
class?
do like you work up to it kind of thing. Like you multiply up to 96 kind of thing. They're like, oh, you don't know what 8 times 2 is? That's okay, you can just do 8. And I'm like, so basically you're counting up to that.
Counting is something big.
But yeah, it was something where they drew like a box like this or something. And they had 96 here. And it was like, oh, I know that 8 times 2 gets me 16. So that brings me down to 80. Okay, I know that 8 goes, so that brings me down. Like, and it was just,
That's long.
Oh,
it was like this whole thing that they were doing. And
when did they
it's,
stop teaching long division and start teaching that?
well, and it hurts my heart because when you get to polynomials, you have to do long division. So I'm going to get to a point where I'm going to get these kids that are going to be like, what is this?
tenth grade or
Okay, so if I take the square root of both sides, yeah, I had a kid that I was tutoring, and they said, yeah, I'm not allowed to talk to anybody above the age of whatever on how to solve my homework. And I was like, okay, well, I'm in that age range. So, but they were like, it was the Common Core math, and I was like, they're not wrong,
Oh, see, that's
because
why.
I want to teach you this. So they were like, don't let them teach you the other. I was like, who cares? If they get this, let them do it. Whatever. Okay, so if I want to reduce 12, okay, if you're a perfect square person, you would see 4 and 3. Okay, then that would get me 2 root 3. If you were someone who divided, you would have also gotten 2 root 3. Okay, so whichever method works best for you, you use it. Okay, but that is why we learned the lesson yesterday on how to reduce radicals and how to deal with complex numbers. Okay, because we want our answer in the most simplest form. What do you notice between all of the problems we have done so far?
They're all pretty cool.
All pretty cool? Okay.
yeah, long division.
Okay. So notice the difference, not how we solved the problem, the original problem. What do you notice? What?
Even numbers. The numbers are even.
Okay, not so much what numbers. I think that was coincidence.
There are only 2 terms.
Only 2 terms, okay. So if you're, and I had it up here earlier if you paid attention, we have standard form. What's missing? The b value, okay. When you don't have the b value, that's your hint that you need to solve by square roots, okay. That's usually your hint. I don't have a b value, I don't have a b value, I don't have an x, just an x, I have x squared. But if I don't have a b value or an x, that's kind of like my, hey, solve by square roots, okay? You're going to get to the end of this chapter where you're going to be like, now, how do I know which method I use? Okay, so I'm trying to give y'all little hints as you go along, which one's the best for me to use for which situation, okay? All right, let's try this one.
Any seniors taking the ACT with the last
name with initials C and D, please go to the library at this time.
Initial. It has to be, you got your first name has to start with C, and your last name has to start with D. If it, how it is, don't come. You're not allowed.
To each
There's
possible
something
combination.
terrifying about making announcements.
You're not welcome.
There's something about it where you're just like, everyone's gonna hear my voice.
You heard that
Oh,
earlier,
yeah,
I couldn't
I'll
figure out how to turn the mic off.
Well,
All right, someone walk me through this problem. Anybody? All right, Peyton, go ahead.
Divide by 5.
Okay,
Then you get 4.
Okay.
Then you square root it plus or minus.
okay,
And then that's 2 because the square root of 4 is 2.
plus or minus 2, right?
Yeah.
Cool, thank you. Okay, so those are pretty straightforward, but again, this pops up on a test and y'all are like, I don't know how to solve it. And I don't know what it is. I think it's the
Seems too
level that we get up to. But you see something like this and you're like, and then you take the square root of both sides and without taking the 5 away and things get messy, okay? So just make sure you remember these. All right, try these 3. Who wants to walk me through the first one? All right, go ahead.
Add 6 to both sides.
Okay.
Isolate x squared, and then find the square root of 49, which is x equals positive or negative 7.
Awesome. Thank you. Someone else for number 2. No?
divide by 8,
Okay.
then find the square root of -16. And, the positive and negative square root of -16.
Okay.
But you come out with positive or negative 4i.
All right. Well, that was supposed to be a little loop-de-loop there. You got the next one?
Yeah.
Okay, go for it.
You subtract 3x squared on the left side.
Hold, please. Why aren't you letting me extend the page? Oh, there you go. There she is. Okay, go ahead. What were you saying? I'm sorry.
You subtract 3x squared
I like that, so I don't have to deal with negatives.
Two x squared equals 800.
Oh, you're quick. Okay, now what?
Two,
Did I vote two?
and then x squared equals 9.
Okay.
And then square root of x equals plus or minus 3.
All right. Any questions on those three? Notice how the last one, even though it had x squared twice, it still doesn't have x with b. So we were able to move those together. That's why I think it was in here, maybe 7 a.m. Someone said x on one side.
Seniors with the last name starting with E or F, report to the library to pre-grid for the ACT. Seniors with the last name E or F.
Been rehearsing that the entire time, like since the last.
They're different people. Yeah.
No, she was like,
Like so you had like the
students with the last name E or F, please.
it's like stage right, but with like gesture voice.
Okay, y'all try these two. Make sure you reduce your answers. Simplest radical form. Okay, someone new that hasn't walked me through a problem. How do I do number one? Patiently waiting.
Dan, you threw me under the bus yesterday.
Yeah,
I think
dang.
yeah.
That was in theater and you like acting.
Mm,
You auditioned for that class. I didn't audition for this.
Is math not your favorite?
No.
Interesting. Okay, walk me through the first one.
Okay, so
Yeah.
x into the other side, you get 4x squared equals.
Whoa, that's
you
fast. Okay, hold on.
divide by 4, you get x squared equals 10 or something. And then you.
Oh wait, we're already to that step. Hold on.
You get x squared equals 10, and then you square root it, you get x equals plus or minus square root of 10, and that can't be reduced, so there you go.
Just like
So sweet about it. Okay, so I can't divide. I can divide. I get 2 and 5, but there aren't any pairs, and then there aren't any perfect squares that go into 10. So that one is completely done. Okay, number 2, someone that is new.
Yeah, dang.
No, he's already done it. He's not new anymore. All right, yeah. Okay. Okay.
Immediate x equals 2I squared plus or minus 2I squared.
The what?
Right.
Okay. So plus or minus 2I square root of 5. So if we reduce 20, we can do 4 and 5. Or if we divided, we would also still get 2 root 5. Remember the I kind of fits in right there. I'm going to make this a little bit more legible. And we have our answer there. Okay. Any questions on those so far? Okay. Let's take a quick break. And then we'll finish up.
That's there for like 30 seconds. Keep it to it. Alright, that's okay. Dude, how many numbers?
31. Let's see. Yeah.
$6.
And then they'll make it on easier.
$6.75.
You always have some nice stuff.
No, that's
No, that's what I bet.
okay, never mind.
I mean, hey, I'll stick that, I can $6. I mean, if they have willing and ready to put it out.
Well, I was willing that it would like to put it out.
Give it to
When I was looking at it next year. Or
Yeah, just.
yeah, it is.
Wow. Wow.
And I
I literally saw the girl that sits next to me in chemistry today.
so,
She was doing her work. She was not even finished. She was like this. Like she fully extended.
Like, how long?
Yeah, no, she was like fully extended.
so we'll see.
And I'm like, are you comfortable? She's like, yeah. And I'm like, didn't even look away. Just like,
Okay, not even gonna lie, this actually is kind of comfortable. Like if I'm just sitting around at the computer and that's all the work I'm doing, I'm not like used to it. What?
I did have her.
Well, do it at a slight diagonal, so that I don't know, taking your chair a little bit.
She was like, I hate the life of this, so I feel like I'm in a hospital, and I'm like, yeah,
We
she's
are.
like, plus they make you look really bad, and that's the worst part. And I'm like, yeah.
Mommy.
But yeah, I was looking at that and I'm like, I
One of yours.
I woke up because now I was in hospital, that I'm 60 years old.
Yeah, you were in a car crash when you were like 7 and you couldn't come up for 20 years.
And so I went from 7 to 60 in 20 years.
I mean, hey man, if you rapidly age, you get in a car crash, you know how
I was like,
You know how
get in
people-
a car
You know
crash.
how people say like the camera has like 20 times or something? It's like that, but with the car crash thing. 40.
Every 20 times.
You're like, I'm
Is someone recording this? Please stop, please.
40 years.
What if it literally added like, so just for the period of time that the camera's on, you just gained 20. And then as soon as it comes off, it takes.
Well, I was thinking more along the lines of like,
Like,
as soon as they point it at you, you gain 20 pounds and you can't lose it anyway other than exercise. What is this? I was watching this video of like fucking news now. Someone in Australia talking about like worshiping the Bible. And then just out of nowhere, Chris Hemsworth just shows up and then just like grabs the microphone and explains about how there's a bunch of cultures he knows about it. Literally, you can tell by the faces and reacting everybody.
Were y'all talking about inappropriate things while it's still recording?
No, I'm talking about Chris Hemsworth.
Yeah, and horses.
Smoking hot, right?
Yes, actually, no. He and Sam Heenan, Jamar Moore. Oh my God.
Yeah?
Yeah. You know who Sam Heenan is? I know you know who Jamar Moore is. Come on.
Yeah.
Jamar Moore is not hot.
Yes, he is.
He's not. He's like attractive, but he's not hot.
Yeah, he is.
He's not.
Hold on.
Any of them is word.
He's a Scottish actor here.
Dang, put your point. Let me see.
The hair could go.
Here, hold on. He looks better with short hair. Let me-
And show me.
I'll put this on. Oh, yeah, there he is.
Short hair is 10 times better.
Short hair.
The whatever he had going.
Well, that's because he's an Outlander, and it's like set in the 1700s.
He kinda looks
Nobody
like
like cut their hair.
Okay, gotcha. Gotcha.
I just played Rowdy.
I learned so much from you, Dane. Okay. All right, so here we go. Let's finish this up, and y'all have probably way too much time to work on your homework. Maybe you can knock out the homework you didn't do last night.
Uh-huh.
That was a good one. Okay, so we can up the game just a little bit, but the rules still apply. I want x, if you will, in parentheses, squared by itself before I take the square root. Okay? What's inside stays. All right? That's what we need to say. But if I look at this and there's nothing being multiplied in the front, nothing being added on or subtracted on at the end, I can jump right into taking the square root of both sides. Okay? So, I'm going to do just that. And writing our answer gets to be just a little bit more interesting. We have already reduced the square root of 20. We got 2 root 5. You need to see that in action again. Okay. Now, we don't add 1 to the 2. The 2 root 5 is a package deal. That stays together. Okay? So when I am going to solve for x, I am going to add 1 to both sides, but where I'm going to put it is in front of the plus or minus. Okay? I am adding 1 to both sides. You have to consider 2 root 5 is a number. Okay? 2 times the square root of 5 is an actual number. So we can't just add that 1 to it or it'll get really ugly. So we can just put it in front of it. And then the last step is to divide by 2. So if I look at my solution here, and this is where that Dorito chip I was talking about still applies. If all 3 of these are divisible by the same number, then I can reduce it. Okay? But 1, 2, 2, I can't take that any further. Notice how I don't even touch what's inside the radical. That's a whole new ball game. I don't even mess with that. Only the outside 3 is what I'm looking at when I'm looking at if I can take this further. So as ugly as it looks, that is our answers. Okay? Now, Notice how every single problem we've been doing is to the second power. It's all squared. It's a quadratic. You should have 2 answers every time. And we have. We've had the plus or minus, so that makes 2. Same thing here. My solution is 1 plus 2 root 5 over 2 and 1 minus 2 root 5 over 2. So I still have my 2 answers. But again, remember, mathematicians are lazy. They want to find a way where they don't have to write it more than once. Okay? Questions on that? So there's a difference between how we get to leave our answer like this and how we get to leave them on these problems. Okay? So let's go ahead and try these 2. See if you can write it out as simple as possible, simplified as possible. Try not to break any math rules. All right, so if I subtract 7 first, I'm going to get 36. And what I would highly suggest doing is separating this into 2 equations. Okay? And what I mean by that is, if I take the square root of both sides and I have plus or minus, I'm going to get 3x minus 9 equals plus or minus 6. Naturally, what happens is when there are whole numbers like that, we want to fall victim to this. But that's incorrect, okay? We cannot just add this 9 to a plus or minus 6. It's going to a positive 6 and a negative 6. 9 plus 6 is 15. 9 minus 6 is not another negative 15, okay? So you cannot, do not do that, okay? So a couple different ways you can do it. And that's why I said if you do it 2 different equations, it keeps you from making that mistake, okay? So then now I can look at it and say, well, if I add 9, yes, here I will get that x equals 5. And here, if I add 9, I get 3, which means x equals 1. That's a whole lot different than plus or minus 5, okay? So make sure you don't fall victim to that. Another way you could have done it is just like we did the last problem, okay? Some people might have done, okay, well, what if I take 3x and I add my 9 and then divide by 3? And you can do 9 plus 6 divided by 3, 9 minus 6 divided by 3. Or I've had students even take it a step further and say, well, they're all divisible by 3. So that's the same thing as that. I can do 3 plus 2 and 3 minus 2. All right? So there's multiple ways of doing it. Just don't do that way. Okay? There's a difference between how we treat ones with the radicals and how we deal with the ones that are actually pretty numbers, okay? If you run into an imaginary number, you're going to treat that like we treated the radical answer. We're just going to put things in front, things after, and all that, okay? So if I add 18, negative 67 plus 18 got you what? Negative 49. I square root both sides. I get 5x minus 1 equals plus or minus 7i. So like I said, we're going to treat that the same way we treated the radical answers. I'm going to add 1. And then divide by 5. And the good news is that I don't have to simplify that any further because 1, 7, and 5 aren't divisible by the same things. You could if you wanted to, but you don't have to in this case. You could write it as 1/5 plus or minus 7/5 I. You don't have to. I'll accept this. When we're solving, you don't have to write it in standard form like that. I'm not going to be that picky. But I just want you to be familiar in case you're on a state test and they do put it that way. Okay? So radicals and imaginary numbers, we're going to treat those the same way. But if it turns out where your radical reduces with a perfect square, I want it all the way down to the pretty number. Okay? Any questions on those? Okay. For some reason, on your last test, the problem that talked about the bottom, or when does it reach 0, or when does it reach the bottom, or something like that, y'all went AWOL on that, okay? Not all of y'all, but some of y'all. When it talks about hitting the ground, what's that value? 0. Okay? So they are asking me how long, so that's time, does it take for it to hit 0? Which means how long does it take to equal 0? Okay? So go ahead. And figure out how long it takes for this rock to hit the ground without a calculator? Simplest radical form. I will give you one hint. There's a property that says if you have the square root of a fraction, you can take the square root of the top and the square root of the bottom separately. All right, let's see how far we got. So if I subtract 1,000, and divide by -16, I'm just going to write it normal. Okay. And then if I take the square root, and if I am looking at the square root of 1,000 over the square root of 16, the good news is I know the square root of 16. That just gets me 4. And if I'm without a calculator, maybe I don't know that a perfect square goes into it. I can just start dividing. And then usually by that point, I realize, oh wait, duh, 100 goes in there. But maybe I didn't see that. But I have a 2 and I have a 5. So that means 10 goes out there. And a 5 and a 2 are left over as well. So I'm left with the square root of 10 inside. But if I would have known the perfect square was 100, then 100 times 10 gets me 1,000. Square root of 100 is 10 root 10. However you want to approach that. Can that be reduced any further? Sure can. 10 and 4, the outsides, are both divisible by 2. I'm not touching this one, just the 2 on the outside. So I get plus or minus 5 square root of 10 over 2.
Seniors with the last name starting with G, H, or I, please report to the library to pre-grid for your ACT. G, H, or I.
Okay. So if you did perfect squares or you did the ladder to break down 1,000, I don't care how you approach it. Now, if you had a calculator, it'd be a different story. Okay. Anyone see a red flag about my answer? What you got?
It's not in two separate fractions.
Okay, it's not 2 separate fractions, which is fine. But if we did put it in 2 separate fractions, it'd probably give me my red flag. Why am I saying there's something wrong about my answer? What you got?
Because it's asking how many, or when the rock hits the ground, and it only hits the ground once.
Okay, so which one are we not involved with?
The negative.
Yeah, negative time. You have to remember in a word problem what you're actually solving. Good job. So in this answer, since I want to know how long it takes, I'm not dealing with negative time. I'm only going to have my positive answer. So that's the only thing that can get you on a word problem. When you're looking at your answer and you're like, whoa, 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 can't have a negative time there or a distance. Okay? Any questions about that? Yeah.
So I got the same thing you did
Uh-huh.
after reworking it. I messed up the first time, but it still works. I recognized that 16 was a perfect square, and it was next to t squared, so I just squared all of it immediately and got 4i and 10i to the square root of 10, and then you can divide them, because if you divide two things, it's just one.
Oh, you took the square root here?
Yeah. And I just did it right away. And I got the same answer.
I think that was lucky.
So,
I would make sure t
Well-
squared is by itself before you take the square root.
okay.
I think that lucked out. Because if it was another problem that maybe one of them was positive and one of them was negative, then your eyes would have never canceled out like they did. So I would make sure that that's gone before you take the square root. Any other questions on that? All right, cool. Go ahead and get started on your homework.